Hi everyone. So in today's video, I want to speak about closures, so anonymous functions or capturing lambdas in the context of GoLang and DMN FEEL. So very, I would say, kind of like strange video maybe. And I should really prequel that when it comes to GoLang here, I have really no idea what I'm doing. So the meme is just to warn, I'm learning GoLang and I found something interesting that I want to share and actually maybe start a dialogue if somebody in the audience thinks that some corrections are needed. But as well, the concept that I've seen, or the things that we will see in this video today, also transpose to DMN, which is more of my jam. So with that in mind, let's move to the content of the video. So as I'm trying to learn Go, I stumbled upon this article here, and what they go about in detailing is a change in the scope for the for loop variables. So we are speaking in typical for loops. You will have maybe some variable declared as part of the for loop. So we're speaking about the variables that typically you define here, and then how the actual scope for this variable will change in future version of Go. And I will have the article linked down below, and also for those of you that maybe prefer like a video commentary, a video comment while reading the article, there is also a nice cover up by a video that I found that I will link down below. What I think as at least myself as a newcomer to this GoLang, what I found most helpful was to look first at this example that actually I'm going to comment just to set the context for this video. So as you can see, it's like we are defining a for loop with an I variable that is part of that for loop scope. And what basically happens here is that we have an array of anonymous functions, so these lambdas that are capturing I, in this case here. And then in another for loop, subsequently, those are executed, those closures, those functions. What ends up happening is that the end result of this is not what you would expect. And this is in fact the reason why this change is going to be introduced. So again, please refer to the article for the full scope of this and current solutions that are available and how the behavior will change. Now, while I was reading this article, and again, here is me being a newbie to the GoLang, I thought, okay, but how really often this can happen? Because truly, yes, indeed, mostly it's about concurrent code. It doesn't happen always with concurrent code, as this example shows, but I really thought to myself, really, what is the likelihood that I will stumble on this as I'm learning the language myself? Well, actually is more common that you may think. So let's move to some table test based testing. Here what we have is that we have defined these two rows, we have our test name, and basically this is just a simple test to showcase, okay, here I have some input and I want to check if the uppercase of this a string would correspond to this one. So very simple test just to get the gist of it. And then this is just a standard scaffolding code that I implementing. And what ends up happening is that I want to check indeed that the lower, so this column here, once it is bring to uppercase, will correspond to this output. So pretty simple, right? Okay, so what happens now if we run this test like it is? You will see that actually is running the second row, so the last row here, twice. And basically it will happen that it will show the last row. So in this case, just the example here, just to get the gist of it, is that we have this as parallel. So if I save this one and I run it again, now this will not show that unfortunate behavior. Of course, the real solution, sort of like it is more that as the article demonstrate, and also as most of the linters actually propose you to fix with, is that you sort of like redefine or you shadow the variables that are part of the for loops. as part of your block of code. And then if I save this one and I test again, now it's running in parallel, we can see that, and we can also see that this is now testing the real rows of the table test-based testing that we have here. Now, this is a very simple and trivial test, but as well, I followed an online course that actually is a very good course, and in some of the recording of the live coding, you will see that this sort of like overlook happens. And actually the code that you can check out, this is not the case, but again, is to show that really even in the best of test courses, and Bill, if you're looking at this video, let's say your course is awesome, I invite everyone to check out that Go Ultimate Training course. It's really, really good. It's really, really great for somebody that is coming to learn Go. It gives a very good introduction, and this was a funny Easter egg that I found, because you see in the video, then you check out the code and it's fixed correctly. So this again is to show that, yeah, this stuff can bite. And truly, even more, thanks to a colleague, actually, they pointed out to me at this issue on the Kubernetes. And while running the linter, of course, there are a lot of sort of like false positives for these kind of troubles. There are truly, actually, from what I've been told, is that this also has occurred as well there. So actually, not all the tests that I were defining the table were actually run. Fortunately, no bugs was uncovered because of this. It was only some testing modification that was needed. But again, just to show that this stuff is not as trivial as it may seem. So I have to say that so far, I really appreciate, as I'm learning Go, also as well seeing that this fine-tuning of some of the stuff that maybe sort of like a showcase in behavior as we are running more and more production code are getting approached and are getting fixed in a progressive way, and also with truly a path forward, also as well to avoid some of the things that you have to do just to please the mechanic and the behavior of what you want to do. So this is for what concerning GoLang. We can now move to see analogous things in another expression language, DMN FEEL. Alright, so now to see an analogous in the DMN FEEL, what I started here is the key sandbox. So again, in your browser, dmn.new, and I'm going to use it as a exercise playground. So what I'm going to have is just a very simple decision here. We can make a context, so we can say this one is, we call it XS, and we are just going to have a very simple expression. So what I'm going to write here is something that should mimic the things that we've seen, in this case for the closure scoping. So we say for I in 1 and then 1 to 10. I don't know why it became bigger, so let me just come back here. And then for I in 1 to 10, I want to return. So we've learned that that happens with the closure capturing. In this case, we want just simply to capture I. So what is this XS is simply a list of anonymous functions that are capturing I. And we would expect that they just, when invoked, they just return their own number. So 1 to 10. So YS, we've learned here what we will need to do is that we can go and iterate on those ones. So for fn in XS, so what we want to do in this case is that we have the function and we are just going to invoke it or evaluate it. And then finally, what we want as the result in this case is only YS. So here we would expect is a list of number 1 to 10. This is very simple exercises on the mechanic of FEEL. And then actually if we go and run, we see that the result is not as we would expect it. And actually, as I was planning to make this video, what I thought is that surely that problem cannot have happened in DMN FEEL, but you know, bug happens, and though rest assured that there is already a pull request being sent on the Apache incubator as well that already fixes this behavior. Now, truly it is to be said that I don't expect these cases to happen a lot, if almost ever. Also because we've seen some times ago, I will link the article down below, I wrote a blog post where I illustrated, also thanks to a colleague support, we implemented very extensive support of Clojure, and even going as far as demonstrating the y-combinator on top of FEEL. I never heard any comments about those kind of like implications, so I don't expect that this happens truly, but it is something that needed to be fixed. And so also just to showcase another possibility, if we go from 1 to 3, then again is the list of only trees. But with the fix, these will behave as you would expect. So the Clojure here would capture the for loop variable scope at the iteration level, because this is what we are expecting, at least for the specification of FEEL. Now, indeed, I was not expecting to see very similar problem or in these edgy cases for DMN FEEL. Truly, it is much more limited in scope of GoLang, but here is something that I wanted to share with you today, and this is really the power of having not only the ability to or the opportunity to learn new languages and also see the concept, but also the transparency that also typically happens with an open source project, and how a concept that you can see in one area under one scope can actually translate very well and improve on other. So this is truly for even more respect. As I'm reading this kind of article for the GoLang, I'm pretty positive and ultra sure that implementing the GoLang it's much more complex than implementing the FEEL interpreter and compiler, but let's say I found value also in this sort of like exchange, and I will have all the links down below. I hope this was interesting as well to see a bit of under the cover on some language, but as well on how I'm trying to approach learning new programming languages. If you found this video helpful, please don't forget to like, subscribe, and leave a comment for your impression. And actually I would hope to start a dialogue, because indeed as I'm learning GoLang, I'm pretty sure that something that I said might not be accurate, so I'm always willing to learn. And of course, as well, liking this and subscribing helps with the algorithm. Is 2023, so we are dealing with the algorithm every day. I hope again this was interesting video for you to follow, and I will see you at the next time. Ciao.